Table 3, tell me a whole number between 0 and 10. 5. Okay, good. You met the criteria. 0 and 10 whole numbers, so if you chose a decimal, you're wrong. If you chose a number outside of 0 and 10, you're wrong. Any of those numbers could be 0, 1, 2, 3, 4, 5, 6, 7, and others, but I'll just stop there. So then next, you were supposed to evaluate the expression using your number for x. So that means anywhere you see an x in the expression, plug it in. Do use parentheses anytime you plug stuff in, especially like when you plug in a negative, it does change the answer. So do that. You can use a calculator by plugging in that whole part. But the numbers really aren't that bad, so we'll just work them out following the order of operations. So what's 5 squared? 5. 25 actually. What's negative 2 times 5? So we'll put minus 10, bring down that minus 35. Now we're on the adding, subtracting from left to right. So it's 25 minus 10. 15, and then what's 15 minus 35? Definitely be a negative though. So yes, -1 is what that equals when you plug in 5. If you chose a different number, then you should have a different answer when you plug in your number. Now, step 3 says, if your number doesn't give a value of 0, which this one doesn't, look for someone in your class who may have chosen a number that does make the expression equal to 0. Anyone think they found that number? Right, Frankie? 7. Anyone think it's a different number? Okay, so then when we plug in a 7 now into the expression, so anywhere that there's an x, we're plugging in a 7. And you can use your calculator to simplify, but don't forget, anytime you plug stuff in, you have to use parentheses. But I'll do it right now. So class, what's 7 squared? What's -2 times 7? What's that? -14 minus 35. So now from left to right, do your subtraction. What's 49 minus 14? What's 35 minus 35? Okay, good. So 7 is the number that makes it work. So 7 is a solution. Solutions are values for the variable that make the statement true. Questions so far? Number 4 says that there's another number that would make the expression true. So also when you plug it in, it'll equal 0. Can you find it? Does anyone know what that other number is? Correct. 9. We have 9. Well, then we could try 9. Are you guessing and checking? Okay. So the first few parts of this was more so like a guess and check. Normally on the test, it won't say your answer is going to be something between 0 and 10, right? So it was just kind of having you practice that. Also practicing when you plug it into the expression, what's the output? So if I were to graph this, which like you still need to know how to graph things by hand, normally you can pick what your inputs are. So just like how you might have picked 5 or 7, you pick those numbers, plug them in, and that's how you get your output. Like when my input's 5, my output's -1. When my input is 7, my output is 0. Anyone pick other x values and have those outputs? Okay, you could continue the table in any sort of direction. You know that quadratics are U-shaped. So you'll have parts where it should be constantly decreasing the numbers. And then a turning point, and then where it starts to increase. It shouldn't be like flip-flopping back and forth. Like earlier, someone told me that when they plugged in, I want to say it was 6, that they got a negative 63. And I was like, no, that's weird. Like it shouldn't be going from here to here to here, unless this is my vertex or something like that. So we checked it and it wasn't that output. I don't know where they got that. But you should see that it's constantly decreasing or increasing up to a certain point, and then it switches and stays consistent. So you could add more values and see what numbers it could possibly be, but that's a little inefficient. So think back to what we've been learning. What have we been doing with expressions that look like that? Turning them into factor form, especially because it's equal to 0. If I switch it to factor form, then I can apply my 0 product property. But only when it's equal to 0. Ron, open your eyes up. All right, so how can I make it into factor form? I showed you lots of ways to organize your information. But basically, you need to find 2 numbers that multiply to get this number and add to get this number. I like organizing my information like this, but it's up to you. And we know that 7 is one of the solutions, so that should hopefully narrow it down. What times 7 will give me a negative 35? Table. Okay, thanks. Negative 5 works. Does that make sense? But otherwise, like hopefully you'd be able to do it when they didn't give you any of the factors. You can just figure out what you need to multiply to get to the top and add to get to the bottom. And actually, if I'm adding to get a negative 2, the negative should go on the 7, but that's a little weird. Give me 1 second. Okay. So, sorry, little, forgot something. Which is a common mistake that you guys can probably make too. So now that I remember, this does make sense. Okay. So I was confused because I was like, well, if it adds to a negative 2, then the negative should go on the 7, which it should. So for my factor form, the negative goes on the 7, so my factor form of this looks like this. But we are right that the solutions are a positive 7 and a negative 5. So the other number that makes this true is negative 5. Why is that the case? Why is it opposite of what we put in the diamond? All right, does anyone remember what we would normally do to continue solving from here? So these are all things we've learned before, now we're just putting them together. If I have 2 factors that multiply to give me 0, what is true about one of the numbers? One of the numbers, one of the factors must be 0. And it could be either one. So that's why we would apply the 0 product property at this step. Set each factor equal to 0 and solve them separately. What minus 7 would give me 0? Table 6, can you tell me what minus 7 gives me 0? Okay, good. That's why 7 was one of my solutions. And table 7, what plus 5 would give me 0? That is why these are the solutions. Although when we were doing the factoring, that was just to get to this step. Our solutions is what we have to do when we're solving for 0. Okay, so remember, solutions, what are other words for our solution? X-intercepts. What else do we call them? Zeros. And also roots, although I feel like the others just make so much more sense. Solutions are values for the X that makes it true. X-intercepts, by definition, are when Y equals 0. So like this expression has an input. Right now we're saying the output is 0. That's the Y is 0. Zeros, like literally what it has to be to make it 0. They're all talking about the same thing. So now attach what you've learned about going to factor form. And now we're setting it equal to 0 and solving for our zeros, our solution. Does that make sense? So that's the goal of today. It's to solve problems that previously we were only able to solve by graphing. Now we're going to solve them by factoring. So really, I shouldn't let you use graphing on your quizzes or your unit tests, but just know like there are going to be questions on your tests that you can't just use your graph to solve, and it'll be more like procedural. So you do need to know these procedures. So in this one, Tyler solved this equation, n squared minus 2n equal to 99. He wrote out these steps. You need to write down what he did in each step. So here's my given problem. This is great practice for geometry. You'll have to do proofs. But what did Tyler do to go from the original to this step? What's the difference? Here you go, 8. Can you tell me what the difference is between these two? Sometimes what we're looking for is really like not that complicated. Okay, subtract 99. As far as like what the difference is, the answer can be as simple as one's equal to 99 and the other one's equal to 0. Sometimes when I ask like what's the difference, it's really not like meant to trick you or meant to like make you think that hard. It's like, what's the difference between these two lines? They don't look exactly the same. So figure out what the difference is and what they have to do to make that happen. And yes, subtracting 99 is how you can go from 99 to 0, isn't it? So for step 1, you could say that they set the equation equal to 0. And you can say by subtracting 99, but I think that's pretty clear in my regular class. Now you do the rest. Tell me what he's doing in each step. Now what is he doing to go from this to this? And this to this. And that's what I need. From here to here. They change it to factor form. Perfect. When they do that, when they go from standard to factor form, they actually call that factoring. And since we're talking like in past tense, I'm going to put that Tyler factored the non-zero side. So the left side changed to factor form. You guys would probably recognize that from setting up like diamond method and picking two numbers that multiply to the top but add to the bottom. And according to Tyler, he thinks that it's -11 and +9 that do that. Say he's correct. On your test, they'll often show you steps, and you have to figure out where the error is. Not saying there's an error in this one, but like, that's good practice. Seeing, is you right? Yes. That does multiply to -99, that does add to -2. So he factors the non-zeros. Table 1, can you tell me what he did in this step? So that I think would be more going from here to here. Or what do you think? Okay. So that part didn't change from here to here. What part did change? So the parentheses, they separated them and made them each equal to 0. Because if I have two factors that multiply to give me 0, one of them must be 0, and it could be either one. So to summarize that, is that from here to here, they set each factor equal to 0. That's what they did. There was one equal 0, now there's 2 equal 0. And the parentheses are separated. So they set each factor equal to 0. And then table 2, what did they do going from this step to that step? They isolated the n. They solved for n in both cases. Because again, it could be either parentheses that becomes 0 to make it 0. So that's why most of the time for quadratics there's 2 solutions. So if you follow these steps, this is how you solve by factoring. In any situation, I generalize them so that it works in any situation. The factoring might be different depending on what it is. So like when we go down to this part, I can tell who watched the video yesterday like they were supposed to. Because in the video yesterday, I taught you how to solve it if it's this. Technically, you don't use the diamond method if it's this. Let's see if you can solve all of these. The first two, I'm confident, because I was here when I taught it to you, so you were paying attention, we should be able to do them. Otherwise, maybe take out your notes, have them ready. Later, we're gonna do a quiz anyway, so you might as well just have them out now. These are good practice for what will be on your test. So you're not just factoring, you're getting your zeros, but the variables have to be to make it true. Question? Okay, so try those. I'll give you 3, maybe 4 minutes max before I start asking you for the answers, and then we're thinking of this. Yeah. All right, so the very first one, as the you try, am I able to just go ahead and start factoring the left side? Did you guys find a number that multiplies to 12 but adds to -8? Did you guys do that first, or? Okay, read the steps. This is supposed to be like a good example problem, the one that Tyler solved. Not 15. Well, anyway, there's steps on your paper that you should have written down, so hopefully that there can be there for you. What does the first step say that we wrote down? Make it equal to 0. Is this equal to 0 right now? So first step is you have to make it equal to 0. So if you just started factoring the left side, then that would be incorrect. You have to make it equal to 0 first. How can I make the 5 become 0? Subtract 5, whatever you do on one side, you have to do to the other side. Sorry, can't see the button. So yeah, whatever you do to one side, you have to do to the other side. Notice that I lined it up with its like term. Sometimes you'll have to set it equal to 0 and it'll be like a 2x that you have to move, or an x squared that you have to move. No matter what it is, you can only combine it with its like terms. So my left side becomes x squared minus 8x, which is 12 minus 5. 7, and it's positive, so plus 7 equal to 0. Now you can factor the left side. So basically you need two numbers that multiply to positive 7 and add to negative 8. The way that I like to organize my information is with the diamond method. What multiplies to 7 but adds to negative 8? Negative 1 and negative 7. So my factor form looks like this. But this one's not just asking for factor form, it's asking for the solution. So now from here, what do we have to do? Okay, get rid of the parentheses by doing what? Look at what the steps we did up here. Good, set each factor equal to 0 and solve for the variable in both cases. So some of them you can guess and check, it's really easy, like what minus 1 gives me 0. Good, so that's one of my solutions. If that's not clear, then isolate it. Do your inverse operations like you normally would. It should be 1 for that side. Over here, what minus 7 gives me 0? Good. But again, if that's not clear, do your inverse operation. That is minus and 7, add 7 to both sides. If you have to well. So don't just stop at your factoring step. That's a common mistake. They'll stop and say my answers are negative 1 and negative 7. Set each factor equal to 0 and solve. Good there. Okay. So the next one, first, check. Is it equal to 0? Great. I can skip that step then. It's already equal to 0. I don't have to do anything to make it equal to 0. So I can just go straight to factoring. I need two numbers that multiply to negative 11 but add to negative 10. Negative 11 and positive 1 do that. The factors of 11 are only 1 and 11. So the fact that it's a negative, you just have to play around with that negative sign until it makes the entire thing true. It has to add to the negative 10 as well. So here's my factor form. X minus 11, x plus 1 equal to 0. Now what do I do? Let's say on my steps up here. Once I factor the non-zero side, I set each factor equal to 0 and then solve them separately. We're solving for both possibilities. That can make the whole thing equal 0. So what minus 11 equals 0? And what plus 1 equals 0? Negative 1. Okay, so if it's not clear, just isolate it how you normally would. Instead of adding 1, subtract 1. Do that on both sides. X equals negative 1 is my other answer. Now this last one, still follow the same steps. Is it equal to 0 on one side? Okay, great. Next step, that's the factor the non-zero side. I cannot use my diamond method to factor when it's a two-term expression. So this is what you should have seen in the video yesterday if you watched it, keep the notes. When it is a two-term expression, well, you could factor by GCF, but technically you haven't learned that yet. We're getting there. It'll come up eventually. But when it's a two-term expression, you have to check if it is a difference of squares. The two-term expression, you're looking for a difference of squares. What does difference mean in math? Is this a subtraction problem? Okay, great. That makes it a difference. The squares part are these perfect squares on each side of the minus sign. So like, what's the square root of 49? 7. What's the square root of x squared? X. So I'll write out the rule, but you should have it in your notes from yesterday if you watched the video. If it is a difference of squares, then it can be factored easily according to this rule. Where a and b would be like the square roots of a squared and b squared. The square roots would be 7 and x. And you'd set them up like this with opposite signs. In that lesson, it proved to you why there's no like middle term, why there's no x term. You can multiply it, it cancels out. And all you're left with is the two terms. This is how you factor a difference of square. Questions so far? So you factor the non-zero side. Once you do that, you can apply your zero product property. What plus x, or sorry, 7 plus x equals 0. What does x have to be? Or do your inverse operations. How do I make the 7 cancel? And whatever you do on one side, you do the other. One of the answers is x equals to -7. Over here, I have 7 minus x equals 0. 7 minus what equals 0? All right, you cannot like, and when you are factoring, just because you like seeing the experts, you cannot just switch this order. This one has to be 7 minus x. So just if it's a difference in squares, have to have a minus in between. We have to be perfect squares on each side, and you write it like this. Second comment concern about this. Okay. So your quiz is in Schoology. It's time for 28 minutes, although there's only 23 minutes left in class. But you're entitled to the time that's on your screen. So if I have to write the pass, I can. You can use your notes. Phone stay in your backpack. I'll put the password up on the screen.